ಆನ್ ಮಾಡಿ ಆನ್ ಆಗಿದೆ. ಹೌದು ಅರೆ ರೇ
ಎಲ್ಲ ಬರ್ದಿಟ್ಟಿದ್ರು ಎಲ್ಲ ಸಿಕ್ಕತ್ತಿತ್ತು.
Very good morning, all of you. As discussed yesterday, we are going to have today with the PowerPoint presentation for the remaining bit of the chapter. I hope all of you have gone through whatever was taught yesterday and day before yesterday. So 2 classes we had planned to make it as a theoretical class, and the remaining 2 classes I wish to make it as a PPT class. Okay, so now let us have the PPT and we'll brush up what all we have studied and we'll take the next part of it. Okay, so if you see this diagram over here, or you can say it's an animation, and in that animation I hope by seeing this picture you people remember the grinding that you people had done for your single point cutting tool. So for your grinding, what you people were supposed to do is the single point cutting tool that was there was taken and brushed or held in connect with this rotating wheel. So you might have seen that unit wherein you had 2 wheels, okay, one at the left, one at the right. So these 2 wheels were rotating continuously at high speed, okay, at a nominal speed, and then you were utilizing the tool to sharpen it or to produce edges, okay, end cutting edge, side cutting edge, end relief angle, side relief angle, and so on and so forth. Okay, so tip, nose, and so on. So you were using this kind of a setup. This is what is your grinding machine as such. So we were discussing about so many things in grinding. So now you can see the grinding that is actually happening. I will just switch off few of the lights so that you can see that picture clear, or the video. Well, so we were looking onto this machine, that is the grinding machine, wherein you can sharpen a tool by using this machine. Okay, so you can observe there are two wheels, and there is a rough surface that is available onto this wheel, and that rough surface you can see is nothing but the abrasive. So abrasive that are stuck onto its surface are helping or performing the cutting action. Okay, this is what you people have done during your sharpening of a single point cutting tool. So you can observe from that you are holding that tool rigidly in your hand and you are connecting it to the grinder or the grinding wheel, onto the surface of which you have all the abrasive particles that are stuck onto its surface. Okay, so this is what I had told you, like we will have the PPT so that we can revise the earlier concepts and go ahead with the next bit of concepts. This is actually what is your grinding operation means. So we are done with the introduction. Okay, few of the points. Again, rough grinder, precision grinder. The types also I have written there, which we had noted on your board, that is classification of grinding machines: cylindrical, surface, centerless, internal grinding machine, and special purpose grinding machine. So the 5 basic types are 5 of these kind of grinding machines. Okay, now next bit, this is what I was referring to. So here you can observe that there are huge amount of sparks that are generated during grinding. So if you see the speed of rotation of the wheel and the friction that is generated at the work tool interface is immensely high, and that is the reason you can see so many sparks are being generated. Okay, that is why I had told you people that we need to use excess cutting fluids in order to minimize the effect of heat, and that heat has to be carried away by the coolant. So the coolant will be supplied at the juncture of the work tool interface, and that coolant will take away all the heat. Yes, so a few more bits, like it is the only economical method of cutting hard materials like steel. In case you want to machine steel, machining of steel is very challenging, right? So it has high hardness, and of course it has huge amount of applications. So that is the reason huge number of people are working on enhancing the machinability of steel. Okay, machinability is nothing but the ease with which that material can be machined. So you can observe here, it is the only economical method of machining or cutting of hard material like steel. Second point, it produces very smooth surface. Grinding produces smooth surface. We have discussed this. Suitable for a bearing surface. Suppose you want to have a precise surface for bearing which fits into an assembly, definitely you need a better finish, and that finish can be obtained by the finishing operations such as grinding. Surface pressure is minimum in grinding. It is suitable for light work which will spring away from the cutting tool in other machining processes. This was the working principle. I was telling you people, if you remember, that an electrolyte, in the top diagram over there we can see that the grinding wheel is rotating and an electrolyte is supplied. What is electrolyte? Electrolyte is nothing but a cutting fluid which helps in carrying away the heat that is generated at the work tool interface. So grinding wheel is attached with the metallic bond, that is your abrasives and bond. Then you have a power supply, right? And you have an electrolyte that is fed in between the work and the tool, and the work is fed towards the right direction. Okay, this is that diagram, 3D diagram I was talking to you about. So you can see how grinder or the unit is actually performing its action. So you can see this is the grinder onto which the abrasive surface is present. This is the workpiece, This will be continuously rotating and will move all along this length of the workpiece. So fine particles are removed. Self-sharpening characteristics, if you remember, we had drawn this diagram and you have explained. This is the process of surface grinding machine, right? So you have a surface grinder in which layer by layer the material can be eliminated. Metal cutting happens layer by layer. We had drawn this in the last class, surface or main parts of a grinding machine, right? This is plane grinding. That is surface grinding. So now if you can see the surface grinding operation, the machine is in 3D. Of course, you can draw the 2D of this as we have drawn yesterday. So you can draw that diagram. If you see, yesterday I was explaining to you all how the working of surface grinder happens. So that is what you can see here. So the parts, so you have the work table here. The workpiece in blue color has been mounted here. This is the grinder which is held by the top mounting head we had written, if you remember. I think instead of that 2D diagram, now you will be able to understand how the grinder has been held in the position and how actually the grinding process takes place. So you have the work material here onto which the grinder will move along its direction. It can move in a transverse direction along x-axis, y-axis and z-axis. It can move because it is mounted on the wheel guard, inside the wheel guard and mounted on the wheel head, okay, which is attached to a column, and this is your grinding wheel. So this wheel rotating at high speed takes part in your metal cutting operation. Can you see here something is written as in feed? What is in feed? It is nothing but the depth of cut. Suppose if you have the thickness of the material as 10 mm, you want to eliminate 1 mm of the material, in feed will be 1 mm. So that much amount of material will be eliminated from the surface. Since this grinding takes place on a horizontal surface, you can call it as surface grinding. Means for any component, the top surface, if you want to reduce, if you want to eliminate that layer of the metal, then we go for surface grinding. So that is what you can see here as surface grinder. Okay. So I hope now you will be able to understand clearly what is that surface grinding operation. Okay. So workpiece is mounted onto the table and you can raise and lower the table. You have the cross feed. Okay. You know what is cross feed in lathe and all, you have worked on it. So cross feed is nothing but this movement. In feed is nothing but vertical movement, and also you can have the suitably and flexibly you can produce the surface grinding process. So surface grinding machine, you can draw this diagram. Okay. So the workpiece is fed against a constantly rotating abrasive wheel and in such a way that one layer of the material is eliminated. So where all this surface grinding is utilized? Where all do we use this surface grinding? So surface grinding is basically used for flat, angular and irregular surfaces. Please remember, surface grinding is used for flat, angular and irregular surfaces. So all these three cases we go for surface grinding. For your examination you can draw this view, okay, so that this is the magnified view. Okay, this is the magnified view wherein you have only the diagram in which your grinder as well as the surface of the workpiece has been highlighted here. But the earlier diagram that you saw here is nothing but it is the machine, surface grinding machine. Okay, so if they ask sketch and explain the surface grinding process, it will be convenient if you draw this diagram. If they ask sketch and explain surface grinding machine, then you can draw this diagram, label the parts and explain in brief, okay, point wise. So this is your surface grinding machine, principle of surface grinding. So if you see, some animation is here for surface grinder. So you can observe there that the movement of the workpiece, see it explains, it just demonstrates. I will also share with you people this PPT so that at home you can go through in detail how is the working of this. Can you see this grinder workpiece? Workpiece is mounted. This is the cross feed. Yes, you can rotate that wheel, and in feed is given from the top, okay, along X, Y, Z axis. So you can see this is your grinder. Okay, the same is mounted on your grinding wheel which you have seen. Fine. So this grinder moves all along the x-axis to remove one layer of the workpiece. That red arrow represents the movement of the grinding wheel, which will help in removing a layer of material. It will chop off a layer of material. Next, so the next part you are supposed to understand is cylindrical grinding machine. Yesterday you have seen surface grinding as well as centerless grinding. So the third part is your cylindrical grinding machine. Now what is the cylindrical grinding machine? So again here the principle of operation goes like this. The workpiece is held between the two centers, that is your rotating grinding wheel is fed against it. So here if you see, for circular components, okay, for circular components you can go for this cylindrical grinding machine. So if there is a cylindrical surface, you want to grind the surface, then we need to use this cylindrical grinding machine. So you can see that what all are the components of this cylindrical grinding machine. You have the wheel, grinding wheel, which is rotating at high speed, okay, revolving. Then you have the feed of the wheel, you can see is in this direction, x axis, because you can see here that the two lines which represent the depth of cut, okay, it represents the depth of cut. Fine. And you can see the work is also revolving, the grinding wheel is also revolving. Both are rotating at some speed, and this, when brought in connect with this workpiece, when the tool, that is the grinding wheel, is brought in connect with the workpiece, you can observe it will go on removing a layer of material, right? It will go on removing the layer of material. That is how it works. Then this will also be rotating at a high speed. Okay, so where we can use this kind of a cylindrical grinder? Now again, to be specific, this cylindrical grinding machine can be designated as external grinding machine. You can see it is written over there, external grinding machine. So why it is called as external grinding machine is nothing but this kind of cylindrical grinders are used to machine the external surfaces. Okay. Similarly, we have another version that is called as internal grinding machine. So in internal grinding machine, we will be having the internal surface of the cylindrical component. Suppose you have a hollow shaft, okay, or you have a drum, okay, which is hollow. So the internal surface you want to do the machining and remove a layer of material. So in that cases, you go for internal cylindrical grinding. At present, this is your external cylindrical grinding machine. I think you can note down if you want some of the bits, okay. So you can write these principles and the type of workpieces that can be machined onto this. So if you see, you can go for machining of cylindrical surfaces, which are maybe straight, okay, or curved, okay. So you can go for such kind of cylindrical surfaces can be machined by using cylindrical grinding machine. Can you see now? Now you will be able to understand it in a better manner. You can see here you have a stepped shaft. 1, 2, 3, 4 steps are there. 1, 2, 3, 4. Stepped shaft is being turned and it is being grinded for producing a smooth surface onto it, right? So if you see there, you can observe that there is a grinder which is rotating at high speed, bringing this stepped shaft, which we call it as an external grinding machine. The outer diameter can be polished, okay, you can grind it. Fine. So you can see there the grinding wheel which is rotating. The work is held between the two centers. I told you if there is a long shaft, okay, long shaft or a rod which you want to grind its surface, in that case you hold it in between the two centers. Once you hold it between the two centers, what will happen? You will have the rigid fixing and it will start rotating. And when this grinding wheel is brought in connect with that shaft, the surface gets grinded. Yesterday also I had explained, I had shown you in the view, you can see that the grinding wheel is moved all along its length. I had told you that perpendicular to the board, you have the shaft length, right? So you can observe here, the grinding wheel starts from here, goes on moving till the end of the workpiece. So outside diameter grinding, which we call it as, or you can generally call it as external cylindrical grinding. The third was centerless grinding. So this is the third type which we had seen yesterday. So the most important types as we had listed are nothing but surface grinding, okay, we have cylindrical grinding, okay, and the third one centerless. Yesterday we had seen this first and third. So in cylindrical centerless grinding, what was the concept over there? So in centerless grinding, the work was held in between the two wheels, right? So you can see that white portion is nothing but your workpiece. The white portion is the workpiece. The left wheel is the grinding wheel and the right wheel is the regulating wheel. We also discussed yesterday what is the function of each of these. Grinding wheel, of course it helps in performing the grinding operation, but what is the work of that regulating wheel? We call that regulating wheel as something simply a support. It is fixed on to a rigid platform and it supports or it helps in providing a proper feed to the workpiece. So workpiece will be revolving there. You have the grinding wheel which is rotating, workpiece is revolving, and you have a support wheel. So again you can note down the principle. Okay, you can just briefly write down this much. If you explain with a proper diagram, you will get those 6 to 8 marks, whatever for which the question is asked. Okay, so you have this diagram is simple. Okay, so you can draw this diagram and do proper naming, and don't forget to represent the directions of rotation as well as the direction of movement. Now you can see for that blade, work blade which is given, it is nothing but a fixed component on which you can support the workpiece, right? So the workpiece can be supported. So you have the grinding wheel which is rotating and grinding operation is being performed. So workpiece is placed on work rest blade, okay, between the two wheels, namely the grinding wheel and the other is the regulating wheel. Both are rotating in clockwise and the workpiece will be rotating in anti-clockwise direction. Yesterday we have seen in the diagram. So what happens there? The grinding wheel removes the material from the work surface, yes, because of the abrasive action, because of the abrasives that are stuck, and the regulating wheel regulates the workpiece. Okay, regulates means what? It gives a proper feed to that workpiece. So workpiece should allow all its surface to get grinded. That is called as regulates. Okay, yes. Next, so workpiece is not held between the centers. Yes, here if you observe, the difference between cylindrical grinding and this grinding is, in cylindrical grinding you hold the workpiece in between the two centers. Here you need not hold the workpiece between the two centers. So who acts as a support? The regulating wheel. So the regulating wheel itself helps in regulating the flow of the grinding operation from one end to other end. Okay. Now, so what type of workpieces are used for centerless grinding? We have the curved or cylindrical surfaces of long slender rods. Now, if the length of that rod is small, then you can hold it in between the two centers. But what if the length of that shaft or rod is too long? You might have seen in various applications they use long pipes like poles, okay, electric poles, or you have some components or some machines in which you need long shafts, okay, long solid shafts which are used for, maybe in case of various applications you can just check. In such cases we use centerless grinding machine. The name itself suggests centerless. The work is not held in between the two centers. Okay, in cylindrical the work is held in between the two centers, right? So that is what is your centerless grinding machine. Can you see here? This is the long shaft which is held in between the adjusting wheel or the regulating wheel and the grinding wheel. You can just observe this. And you can so see those arrows. So work is fed all along its length in between these two wheels. So this is the machine, centerless grinding machine. See, you can observe how the arrangements are made over there. So you have the regulating wheel, grinding wheel, in between that long rod is there, held in between these two. So there is no live center and dead center over here. So the support is given by the regulating wheel itself, the electrical control unit, hand wheel, base, and so on and so forth. Okay, you can draw this also, or you can draw this diagram also. If you want to explain the working principle of the centerless grinding machine, then draw this diagram. If you want to sketch and explain a centerless grinding machine, then you have to draw this diagram. Okay. Now the next bit is typical specifications of a grinding machine. So I want you all to go through all these points and note down these points. Okay, so please note down these points so that this is a specification for a particular grinding machine. Now why I have asked you all in the syllabus to know is, how do you define that grinding machine? Suppose if you want to purchase a new grinding machine, then what are the characteristics that you are supposed to look at, or what are the specifications you have to be little careful about? For that you can just go through these specifications. So grinding mode, so this specification is typically for a particular surface grinding operation. So grinding mode is surface grinding. Then you have the name of the machine as Lamba press hydraulic surface grinder. It is just a name of the machine, or you can say model. Okay, then maximum stroke length. So what is that stroke length? The length for which you can move that grinder. Okay, 750 mm. Maximum cross feed, how much you can move in the cross feed direction. So that is 235 mm. Work area, the total work area on which you can mount the workpiece and do the grinding operation is 450 into 200 mm square. Grinding wheel now comes here. So the next part of the chapter deals with this. What is the type of grinding wheel? What are the abrasives? What is the bond? What is the mechanism? And so on. So nomenclature, which we call it as in short. So you can see the grinding wheel has an aluminum oxide abrasive, Al2O3. Okay, it has Al2O3 abrasives. Again, in that there is some coding, that is AA46, K5, V8. Those are all coding. So we will see what is that grinding nomenclature. Okay, so that they represent the grit size, the bond, the type of bonding, and whether it's vitrate or shellac bond and so on. So we'll see that. Next is wheel size. The rotating wheel size which we can observe is 250 mm into 25 mm into 76.5 mm, 76.2 mm. Okay, that is the wheel size. The wheel speed 1400 rpm. It can revolve at a speed of 1400 rpm. Then the environment can be dry, wet with 1% Al2O3. So dry and wet means what now? What do you mean by that, dry and wet? So you can have the grinding wheel which will be having wet surface or dry surface. So you can supply the cutting fluid or without the cutting fluid. Next, the tool. So that is single point diamond. cylindrical grinder. So if you take an example or a specification of a typical cylindrical grinding, then you can have this specification. Okay, it helps in machining the cylindrical surface. Okay, the next bit of it. So what are the next bits of this grinding wheel? So the next we are supposed to understand what does a grinding wheel consist of, basically the components of a grinding wheel. So you can see the main components of grinding wheel are nothing but abrasive, bond and pour. So during self-sharpening characteristics we had listed these three terms and let us see them in detail. So what are they? The abrasive grain is the element that actually performs the cutting action in the grinding. The choice of the abrasive depends on the material that is to be machined. So, for example, if you take a soft metal, okay, whose hardness is less, then you may have to select the abrasive suitable for that material. Suppose if the material is too hard, like steel, then you have to select the abrasive which can withstand the stresses, or it has to withstand the resistance to abrade that steel material. So based on the application you have to change your abrasive substance. Okay, selection of abrasive is very important. Second is the bond. Okay, all three have been shown there, depicted over in that left diagram. Bond. The bond basically helps in holding the grains together, right? It helps in holding the grains together. But on what basis you can select the bond? That is based on the operating speed of the wheel, the type of operation and the surface finish required. The operating speed, what speed you want to revolve that grinding wheel. Second is the type of operation, okay, what type of operation you are doing, okay, cylindrical grinding, surface grinding, plane grinding, internal grinding, external grinding, okay, rough grinding, precision grinding. Based on that you have to select the bond, okay, because it affects, everything affects there. Next is pour. This exists between the chip or the grains and the bond. Why this pour is essential? To throw away or push the abraded work material, means the chips, okay, the chips that are eliminated because of this grinding need to be pushed to the outside the work surface, okay, or through this grinding wheel. They will get stuck, right? So it has to be pushed, okay. Then the again here the pour can be classified based on dense spacing or open spacing. Dense spacing means what? The abrasives are placed very close to each other, the gap is very less, and open spacing is they are placed little far, okay. That is what is the concept. This is what is about the components of a grinding wheel. Next, now we will see construction of a grinding wheel, okay. We had drawn similar diagram. So it has a bond. The blue color, the dark blue color represents the bond. The red color represents your what do you say, the grains, okay, the grain structure. And there are some cracks. You can observe there are some terms like micro cracks and all. That is because of, again, what? Because of the wear and tear of those abrasive particles, they become blunt. So that is what is. So what are the components of a grinding wheel? So there are basically 5 terms associated, or 5 important things that you should know about a grinding wheel. What are they? First is abrasive, next is bond, third is grit or the grain size, fourth is the grade, and fifth is your structure of wheels. Okay, all the 5 we are supposed to understand. First, the grit or the grain size. Okay, give me a minute. Okay, so you can see the grit or the grain size. See, the size of the grit or grain is determined by the number of screens that it can pass. If you remember, during your sand casting lab, you people had done grain fineness test. Okay, that was one of the experiments in which you make or allow the sand particles. Okay, you take a fixed weight of sand, you pass it through the meshes. Okay, there are number of sieves, grain fineness testing. That experiment we had performed by using the sieves. Sieves are nothing but those nets in which there are pores through which the grains can pass. So here you can see the grit or the grade, the term grit, okay, a number. That number is given based on how many meshes the sand or the abrasive particles can pass. So that is your meshes, number of meshes per linear inch. Okay, so that is what is with respect to the grit or the grain size. Okay, the grain size influences the stock material as well as the surface finish. Okay, yes, of course, the size of the grain matters. Okay, so if you select an appropriate grain size, the finish that you will get will be better. Okay, you can't randomly select the grain size. Then the selection of grain size is further determined by, or it depends on what grain size you can select for a particular machining, for a particular procedure of grinding, what grain size you can select. So that is based on nature of grinding operation, then the material to be grinded, the material removal rate, and the surface finish that is required. Okay, all these 4 parameters play an important role during the machining. Now I wish to show you one chart in which you can observe, yes, now we can observe it clearly. Grit size, the size of the abrasive grains determines the coarseness of or fineness of the grinding wheel. There is a small error, or fineness, it is coarseness or fineness of the grinding wheel. So what is that grit and how do you characterize it? Okay, categorize. Basically, how do you categorize it? Category is done as, if it is a coarse grain, then it has a size of 8 to 20 and used for roughing operation, for rough grinders. Okay, if it has a medium grit 30 to 60, then it is used for general purpose. If it has a fine grain, smaller grains, 80 to 180, what do you mean by this number 8 to 20, 30 to 60? It is nothing but those many particles can pass through that mesh. Okay, so you have 80 to 180, it is used for finishing operation, and very fine grade or very fine grades which are of the sizes 200 to 400, that can be used for jewelry. You remember that for polishing, making fine jewelry, they use the grinding process. So that is what is the categorization, how it is given. Next, what are the types of abrasives? We need to know what type of abrasives are used for your grinding operation. So the first one is aluminum oxide, second is silicon carbide, third is diamond. Okay, of course you can just remember few of them, you cannot remember all, so that's why we have listed few of them for your examination purpose. They may ask you what is the criteria of selection of grinding wheel or grit, and they can ask you some details about these types of abrasives. What are the types of abrasives used for grinding wheel, or explain the characteristic features of a grinding wheel. In that you can mention all these, grit, grade, type of abrasive, type of bond, and so on. You can explain based on the marks. So the first one is aluminum oxide. When is aluminum oxide used? So for high tensile strength materials like steel, malleable and wrought iron, aluminum oxide is used. Okay, it is an abrasive substance. Next, silicon carbide for low tensile strength, brittle material and non-metallic materials. If it's a non-metal, then generally we go for SiC, silicon carbide. Okay, it has low tensile strength. Okay, what do you mean by it has low tensile strength? Yes, is it ductile or brittle? It is less brittle, less ductile. Okay. Okay, so that's why brittle materials, low tensile strength, and non-metallic materials it can be used. Next, cast iron, soft non-ferrous metals, marble stone, and so on. SiC can be used. The last is diamond. For carbide and very hard materials, we can go for diamond as an abrasive. Next, we understood what is grit. Now we will go for what is grade. So how the abrasive particles are termed, the terminology. Okay, what is the terminology that is used? So generally they are indicated by these alphabets as such. From D to H means it is soft. From I to P it is medium, and from R to V it is hard. Okay, the categorization is done, or the nomenclature terminology is given as standard form. That's it. Structure of grains. Now there are three structures in which the grains can be placed onto a grinding wheel. What is that? The first one is open structure or open spacing. The second is medium structure or medium spacing. The third one is dense structure or close spacing. Okay, so you can just see based on the diagram that these are nothing but the abrasive grains. Okay, and this white portion is the bond material, and this black portion is the pore. If you observe carefully, okay, even though all the three diagrams seem to be the same, there is a lot of difference. What is the difference? Here you can see the black portion is thick, heavy. So means they are coarse grains, means they are placed far from each other. The abrasives are far, at a distance far from each other. The same if you see here, the thickness of this black portion is reduced, means they are medium spacing, they have medium spacing. And the last diagram you can see the thickness is still reduced, the black portion is still lesser, means they are finely or densely spaced, that is close spacing of the abrasive materials, right? So open structure, medium structure, and dense structure are the three types of structure of grains. Next, the bonding material. What I was telling about the bonds, type of bonds. So what are the types of bonds? Again we have rubber bond, oxychloride bond, metal bond, and electroplated bond. So where are these used? The application is also given over there. Rubber bond is used in thin wheels, replaced by resin bond. Then oxychloride bond is used, limited use. Then metal bond is extensively used for super abrasive wheels, high toughness, high accuracy, large stock removal, and electroplated bond is used for small wheel, foam wheel, and thin super abrasive wheels. So based on your application, you decide the bond. So what you are supposed to understand is the types of bonds. Okay, you should be familiar with the terms of these, that is types of bonds and their attributes, right? Some more type, vitrified bond. It consists of clays and other ceramic substances, and it is unaffected by oils. Each of the bond has its own specific features and benefits. Okay, and the last one, resinoid or phenolic resin. The last, that is marking system for grinding wheel. I was telling you, explain the nomenclature of a grinding wheel or marking system of a grinding wheel. Suppose if you want to buy a grinder, then on that there will be a strap in which this nomenclature will be there. So what is that nomenclature and what are the terms in that nomenclature? Now we have studied all those, grit, grade, bonding, size, and so on. So just you are compiling all of them and making it as a nomenclature. Okay, so nomenclature goes like this. What is that? It consists of 7 terms, that is starting from 51, A, 36, L, 5, V, and 23. What all these are? Each one you have to just represent. What does that mean? First one is prefix, that is 51. It is a manufacturer symbol. He can have a coding that it is 51 or 52 or 53, whatever it is. The exact kind of abrasive, it represents the exact type of or kind of abrasive. Next, the abrasive type, in detail what abrasive it is, that is represented by A, capital A for aluminum oxide, capital C for silicon carbide, and so on. They have also given the examples. So having asked in the examination, explain the grinding wheel nomenclature or the marking system in grinding wheels, you are supposed to write this one example, a number, and represent what each one of them explains about. So A is for aluminum oxide, C is for silicon carbide. The second term represents the type of abrasive. The third represents the size of the grain, whether it's coarse grain, medium grain or fine grain, that is 36. So the grain size is nothing but 36. You can see coarse, medium, fine, very fine. So in this category, what does that number represent is fine grain, okay? Sorry, medium grain. It is 36 medium grain. Next, L, the grade, okay? You just now saw what grade of the material it is, whether it's soft or medium or hard, abrasive, what type of abrasive it is. So that is L. So L stands for the medium grade abrasive. You saw those alphabets, D to H, I to P and so on, R to and so on, okay? Next, 5. So what does that 5 represent now? Dense structure or open structure, okay? Whether it's a dense structure or open structure, that number represents the dense to open. So dense means what? It starts from 1, 2 and so on, okay? So that is 5. 5 is dense structure. Next, bond type, V. So what is that V? You saw so many types of bonding types there. So what are they? Vitrified, silicate, resinoid, shellac, oxychloride and so on. So what type of bonding it is? So that represents the last but one number, 6th term. The 7th term represents the manufacturer's private marking to identify the wheel. So that is optional. So they can have, see in industry they manufacture huge amount of components. So there should be some marking or some notations onto those components so that they can make it as a batch. One batch is of this vitrified bond, one batch is of silicate bond and so on. So they have the markings. So how many terms are there totally in case of this grinding wheel nomenclature? 7 terms, 51A, 36L, 5V, 23. Each of these represents some term, okay, associated with the grinding details, okay. So while you are writing in the examination, keep some space after 51, space A, space 36 and so on. Don't club them, okay, and put arrows and represent what each of one of them determines or explains to us. The last one, major advantages and applications of grinding. So what are the major advantages? A grinding wheel requires 2 types of specification, that is dimensional accuracy, surface finish, and both are applicable for hardened and unhardened material. So it basically provides good surface finish. What are the applications? Surface grinding, slitting and parting, descaling, deburring. Descaling means what? Remove a layer of the material, descale, paint, we remove that paint, so that is descaling. And deburring. Stock removal, finishing of flat as well as cylindrical surface, grinding of tools, cutters and resharpening of the same. And there are some many other applications also. You can write any of the applications, not specifically what we have mentioned here. Okay, so that ends your grinding part of this chapter. So I think we have covered it extensively. So we have gone through all the details, almost all the details of this grinding, and in the next class we will be starting with CNC VMC. That is the last bit. I think in another 2 classes we will be able to cover the syllabus, okay. So we will be completing the entire syllabus maybe by Monday or so, and already we have taken this week 5 classes are over. This is the 5th class. So tomorrow and Monday I think we will be able to. The total unit is of around 8 to 9 hours, but since we are not having the dictation of the notes and we don't have it's some kind of a one way we are teaching, so that's why it may be covered in 6 to 7 hours. So already 5 hours are over. Another 2 hours we will be able to complete the CNC VMC part of it. Okay, thank you for today. Let's start with CNC VMC by tomorrow. Either me or AVK sir will be continuing with the CNC VMC part. Okay, thank you.